morning. Hello, Bilal. Hello, Fariduddin.
Hello, ma'am. How are you?
I'm fine. How are you?
Allah ka shukr, ma'am. I'm fine.
Great. Hello, Rana Shehbaz.
Good morning, ma'am.
Good morning, beta. How are you?
I'm fine. Thank you, ma'am. How are you?
I'm fine. Thank you. Hello, Maiza.
Assalamualaikum, ma'am.
Walaikum salam. How are you?
Ma'am, I'm good. What about you?
Thank you. Ali Zulkarnain. Ali Zulkarnain, are you there?
यस मैम
क्या हाल है बेटा?
जी मैम ठीक आप कैसी हैं
अल्लाह का शुक्र. Okay, who else do we have? Zarish.
यस मैम.
Hello, beta.
मैं ठीक हूँ मैम. आप कैसी हैं?
I'm fine, thank you. So, Nadia Mukhtar. Hello, Nadia.
Present, ma'am.
Present, ma'am. Yeah, I think you're sleeping. Okay, right. Ibrahim Irfan.
Assalamu alaikum, ma'am.
Walaikum salam. How are you?
I am fine.
Good. Sania.
Yes, ma'am.
Hello, Sania.
How are you, ma'am?
I'm fine. How are you?
Ma'am, ठीक.
ठीक. Okay, good. So let's give a minute for other people to join as well, and then we start. Okay?
Okay, ma'am.
Amelia Samuel.
Yes, ma'am.
Hello, beta.
Yes, ma'am. Hello.
Who do we have now? Let's see. Arisha.
Present, ma'am.
How are you, Arisha?
I'm fine, thank you.
Abu Bakr.
अस्सलाम वालेकुम मैम
Walaikum salam. Hamza Dar. Hamza Dar, are you there? Hello, Hamza. हमजा की जगह किसने लॉगिन किया हुआ है?
Yes, ma'am.
बेटा आप बोलो ना.
Okay.
Right. Okay. One more minute and then let's see. Okay, right. So I think we can start. Okay. And there are a number of announcements I would like to make. Number one, the class will always take place unless if you are informed otherwise. Is that clear? ठीक है? I'm getting
Yes, ma'am.
sometimes messages from students if the class will take place or not. Of course, the class will take place according to the timetable that we are following, unless if otherwise informed. Okay? So the Zoom link
Yes, ma'am.
can be sent on the same day or sometime before. Depends. That doesn't matter as long as you get the Zoom link at the before the time of the class. Okay? So don't worry about that. Okay, number one. Number two, we have a lab, as you know, and this lab material will be uploaded and you can study and practice from there. Okay, so your homework will be for the lab time before 2 o'clock. I will upload the lab material. Okay, so you can go to Moodle and not right now, but during the lab time. Okay, and you can also see videos on YouTube. So these are the platforms that we are using. Okay, so keep practicing the lab. Also, you can study from your worksheets plus the lab material that we are uploading, and then you will be able to prepare for the lab exam that will or assessment that will take place near the end of the semester. Okay.
मैम आप ये कह रही कि लैब की क्लास नहीं होगी कि लैब के टाइम स्लॉट के दौरान हमने जो आप वीडियो अपलोड करके वो देख के उस पर रिसर्च करनी है लाइक
हाँ जी,
एग्जाम के लिए.
Yes, you have to study that. We are planning to upload material related to that, and we are also planning to give you some link where you can practice that. Okay. ठीक है?
Yes, ma'am.
Right. Okay. So class recordings, as you know, are being uploaded to YouTube, and you can subscribe and you can watch those recordings. Okay. So rather
मैम
than
लास्ट वाली नहीं हुई वैसे YouTube पे आपकी.
हाँ, मैं डाल दूंगी उसको YouTube में. ठीक है? ओके, ये कौन बात कर रहा है?
Yes, ma'am. Was.
मुआज. ओके, मुआज. ठीक है, you can subscribe and you can as soon as I upload it, you will know that, right? Okay, and now I would like to draw your attention to the fact that we have completed homework 1 is done, right? Quiz 1 is done, right? And homework 2 is almost done, right? It has been uploaded. I hope some of you have done it, but the deadline for homework 2 was
4th December.
4th December, ma'am.
4th December, right? So let me share the assessment plan with you again. Just a moment. Okay, so this is the assessment plan that we are following. Can you see it? Can you see this?
Yes, ma'am.
Yes, good.
Yes, ma'am.
Okay. Okay, so according to this, we can see that this is done. Okay, this is done. Homework 2 is almost done, right? And now we have to prepare for your midterm. Okay, so the midterm has to be prepared. For this purpose, I will start revision in the coming class. Okay, so please remember, these are topics 1 to 5. Topics 1 to 5 do not necessarily mean chapters 1 to 5. Please be clear about that, as I've already mentioned over here, and I've been mentioning in the classes as well, that the chapters, are repeatedly discussing the topics, and normally the chapter numbers are more than the topic numbers. So you have to look at the topics and relate them to the chapters. So for this purpose, you will do this as a homework. You will prepare these topics for your midterm exam. Plus, we will also practice and revise in the class. Okay, so this is what we are going to do in the next class. Okay, and I think, like, since this has been repeating, homework 1 was topics 1, 2, 3, so these are prepared, but you have to practice and revise them again. Quiz 1 was also on the same topics again, so this was another practice and revision, but now again you should do it. Topics 4 and 5, homework 2 is based on them, but then again I would like you to work further all together on these topics in order to have a good midterm examination. Is that clear?
Yes, ma'am.
So this is your homework. Start preparing these topics. And also I would now like to share the course outline that I've already uploaded with you, so that you
Submit का format नहीं बताना.
beta MCQ problem format. Okay.
Okay.
Let me show you the course outline that we have been sharing with you. Now, as you can see in this course outline, we have topics, not chapters. So please be clear about that, because you can see that, for example, if there's one topic, force and motion, it's in more than one chapters. Okay, it's not just in one chapter, because you have seen that repeatedly the topics have been repeated in several chapters. Like, for example, velocity, acceleration, vectors are repeatedly being used in many chapters. So do the chapters accordingly, identify them, don't be confused about this. Similarly, you have like the topics that come under the heading of work and energy that we're studying at present. These are also in 2 chapters. It's not just in 1 chapter. So please study accordingly. Okay. Keep yourself updated about. Also, we've given you an evaluation plan, and you can see the midterm is from topics 1 to 5. Again, these are topics, not chapters. And you have the final term exam, which will be from the topics 6 to 10. Your homework topics have also been written accordingly, and I've been also giving you the topics for your quizzes. Okay, so this will help you all prepare towards the examination and all the assessments that we have. You also know that the midterm is counting for 25%. Your quizzes are 20%. Your homeworks and assignments are 15%. The lab work is 15%, and the final exam is 25%. Okay, so please, if you're studying after every class, which is 3 times a week, if you sit in the evening and study and practice that material, then you don't have to be stressed out, or you don't have to be burdened, and you don't have to be scared. Okay, you only get stressed out when you keep accumulating the work that you have and you don't regularly study. So I would really advise you that after every class, please make some time in the evening to seriously sit down and study. Study does not mean reading. Okay, study means you actually are able to write down the problems and solve them on your own without help from the book. Okay, then that means that you're ready and you're prepared. Okay, so start working on that. And this is not something you can do in one night or in one day. It's something that you do continuously over a period of time, and then you will be good enough. Is that clear? ठीक है?
Yes, ma'am.
कोई परेशान तो नहीं है? परेशान नहीं होना. परेशानी तब होती है when you are not working regularly. If you're working regularly, like you should, after every class, which is, you have a lot of time, right? You have like Monday, Wednesday, Friday, you can make time in the evening. Usi din, do it on the same day, and then it will be much easier because it will be fresh in your mind. Okay, and as you know that all the problems are using the concept, so you practice and apply your concepts to solve those problems. Okay. Okay, right. So these were some announcements. जी.
मैम लैब का जूम सेशन होगा कि आप जस्ट वो वीडियोज ही देखनी है हमने?
You have to study and practice the material on Moodle and on YouTube. It will not be a live session because you can practice at your own pace. Okay.
और मैम वो उसके क्वेश्चन भी फिल करने हैं जो हमारे पास लैब मैनुअल है?
Try to do that and see how it works. Okay.
Okay, ma'am. Thank you.
Okay, take care. Now, let's come back to the material that we are studying, and I'm going to share the text that we're using. So this is, okay. Mm, where is this? No, not this one. Yes, this one. Share. Okay, good. So this is what we were studying. We are on chapter number. Can you see it?
Yes, ma'am.
Good. So we are on this chapter, and this is what we were also doing in the previous class. Let's look at the main concepts studied in this chapter, and then we apply those concepts to solve the problems. Okay. So let's see. Okay. So before I do this, I'm going to take the attendance. Okay, let's see. So Sarmat, no. Amar, no. Abu Bakr,
Present, ma'am.
Fatma Babar, Muhammad Usman, Anam Basharat, Bilal Muhammad, Bilal Muhammad, where are you?
मैम वो है अभी वॉशरूम गया है.
Are you in the same location?
यस मैम हम हॉस्टल में हैं.
हॉस्टल में हो आप लोग? अच्छा, ग्रेट. ओके. सो हु स्पीकिंग?
मैम फरीद मैम वो अभी आए थे 1 मिनट में.
अच्छा,
बोल दिया था आके
right. Okay, fine. Okay, so yes, I know I did talk to Bilal in the morning. Tell him to tell me when he comes back. Hamza Dar, Fariduddin,
Present, ma'am.
Yes, Kessler is not here. Zarish,
Yes, ma'am.
Muhammad Haris, he's not here. Muaz,
Yes, ma'am.
yes. Okay, Hafiz Ibrahim,
Present.
yes. Humayr Shad,
Present, ma'am.
okay. Alina,
Present, ma'am.
okay. Muhammad Hunain,
Yes, ma'am.
okay. Hunain, you were late.
Present.
Yes, ma'am. Wait.
Rana Shahbaz,
Present, ma'am.
okay. Sania,
Present, ma'am.
Risha,
Present, ma'am.
Chand,
Present, ma'am.
okay. Maiza,
Present, ma'am.
Yusuf,
Present, ma'am.
Abira,
Present, ma'am.
Nadia, Hayan Ahmed, Nadia, where are you?
अस्सलाम वालेकुम मैम मोहम्मद बिलाल है.
Who's speaking? Bilal, right.
Yes, ma'am.
Hayan Ahmed, where is Nadia? Nadia login करके चली गई, I think. Okay, Hayan Ahmed, Cheryl, Ashraf,
Present, ma'am.
okay. Hayan Ahmed, he's not here. Okay, Ashraf, Muhammad Ashraf, no. Huda Zahur, no. Amelia,
Present, ma'am.
okay. Bisma, no. And Sadiqullah, no. Sohaib, Sadiqullah is a hostite, is he? Sohaib Tahir, Talha, Ali Zulkarnain.
Yes, ma'am. Present.
Okay, good. Right. So now the concepts that we studied last time we were talking about kinetic energy, right? We were also talking about the formula that we have also been using, which is very simple. K is equal to half mv squared. And the work done W, we have been using it and defining it. And the formula for this is the dot product of force and displacement multiplied, which means that you have to include the angle between the force and the displacement vectors, which is phi. Then we talked about the work energy theorem, work kinetic energy theorem, where the work done is equal to the change in the kinetic energy, right? And then from here we can find the initial or the final kinetic energy according to the problem that is given. We have been talking about the gravitational force Fg and the work done with the help of the gravitational force. So in this case, the work done is represented with the subscript g, and this is, instead of force, you're using mg, okay, the gravitational force multiplied by the displacement and the angle between the two, the cosine of this angle. Now, work done in the, this can be in the horizontal direction or it can be in the vertical direction. If it's in the vertical direction, then again it's a, you have the applied work and you have the gravitational work, which depends upon the applied force and the gravitational force. Another kind of force that we have been studying in the previous classes and in the previous chapters is the spring force, right? So this spring force is given by the formula which is known as the Hooke's law, in which case it depends upon the displacement from the mean position multiplied by the spring constant, which is K, and this has a negative sign indicating the direction of displacement. And also this, if it's taking place along the x-axis, the same formula can be written in terms of x, where x will now be the displacement. Now, since this is a force, when it's applied on a body, it performs a work, and this work is represented by Ws, and it is equal to the change in the kinetic energy, the final and the initial kinetic energies. So another thing that we've been discussing is then work done by a variable force. So in the initial cases, we talked about a force as a constant quantity. Okay, it had a fixed value, but then we also talked about the case when the force is changing. And in that case, the formula is modified slightly, that we use an integration here. And I've shown you these formulas in the tables that I've uploaded, right? So it's, you don't have to know the whole list of formulas, just the first 2, 3, 4 formulas are enough, okay? So you can use them when you need them. Then the concept of power we know is the rate of doing work. It's the work divided by the time interval. And this can be written in the form of average power, or if you have to find it at a particular time, then you can use this formula. So, and again, there's another power formula which was based on the force and the velocity dot product. So these are the main concepts that we're talking about. Now we'll try to use these concepts and apply them to solve problems, because the best way to understand the concepts is to solve problems. We've already done this problem in the last class, so we'll go to the next one. We have also done this one, right? Okay. So now we go to the concepts of chapter 8 that we were studying last time, which is potential energy and the conservation of energy. So in this case, you can see that these were the topics that we covered, and the main concepts in this case are here. So conservative forces, what is a conservative force, and the fact that the net work done by a conservative force along a closed path is 0. And also the change in potential energy is equal to the negative of the work done. So we talked about this. Then we talked about gravitational potential energy, where we know the formula is mg into delta y being the vertical displacement. Or it can be this is a change, and or we can say u is equal to mgy. We talked about elastic potential energy, which is half kx squared. We talked about mechanical energy and the fact that the sum of the kinetic and potential energy is called the mechanical energy. And according to the principle of conservation of mechanical energy, we have the sum of the work done in one state equal to the sum of the work done in the second state. So, and again, the change in mechanical energy will be equal to the sum of the changes in the kinetic and potential energies. So we also talked about the fact that when there's work, there's also a concept of a turning point. We will use this concept in solving a problem. So the turning point is a point where the force becomes zero and the velocity becomes zero, and the body changes its direction of motion. It reverses its motion. Okay, so if velocity is zero, then the kinetic energy will be zero. We'll just solve a problem to understand this better. Now, the work done on a system by a external force, if there's an external force, then you can also have other kinds of energy in addition to the mechanical energy. For example, one energy that we talked about is the thermal energy, which is in the form of heat energy. So this is equal to the product of the frictional force and the displacement. And then we have the conservation energy, which will be the sum of all the kinds of energies, including the mechanical, the thermal, and the internal energies of the body. So power again remains the same like we discussed in the last chapter. So these are the concepts we are going to use today to solve the problems. Okay, so now let's come here. Let's look at this problem. Now, in this case, you have a figure where you have a mountain slope, okay? And when you have mountains, you have valleys, right? You have a mountain and then the space underneath is called a valley, okay? So, if you have a mountain slope and the valley along which a rock avalanche moves, you know that there are avalanches of rocks on mountains. It happens all the time. Whenever you travel to the north, for example, you come across the road being blocked due to rock avalanches. So rock avalanches happen on the slopes, and in this case, the rocks will fall down, but then they will not stop there. Rather, they will also cover some distance on the path along the valley. So this is what we have to do in this problem. So in this problem, we have been given that the rocks have a mass, let us say m. They fall from a height y is equal to capital H. So the zero position is y is equal to 0. The height is y is equal to capital H. The rocks are falling along this slope. The slope is making an angle theta. This angle theta has been given to be 45 degrees. And the distance that it's moving along the slope is d1. And then after this, of course, the rocks do not stop immediately. That's why it's dangerous to drive along a road when a rock avalanche is taking place. You should not drive along that road. And in fact, traffic should be stopped because the rocks will come and hit the people who are passing through this valley. Okay, so now let us assume that the distance traveled by the rocks along the valley is d2. So in this case, the question is that we have to find the ratio of this distance d2 and the height h of the run out to the fall height if the coefficient of kinetic energy friction is given to be 0.6. Okay, so this is the problem. Now, what are the concepts that we can use in this case? In this case, since there's a height involved, there's a motion involved, and there's a displacement involved, we can use the concepts of mechanical energy of the rock and earth system. And we know that mechanical energy is a sum of the kinetic and potential energy. So E mechanical is equal to U plus K, as we studied before. K is equal to half mv squared here, and U is equal to mgy. So that's one concept that we are using here. What kind of potential energy is this? What kind of potential energy is this?
Gravitational potential energy.
Gravitational, very good. So this is gravitational potential energy. Acha, there's another announcement I have to make. If the meeting ends after 10 minutes, okay, then please click on the same link again to rejoin the meeting. Is that clear? Okay. Right. So this is gravitational potential energy. That's why we're using the formula mgy. Also, is this mechanical energy conserved or not? Hello, can you hear me now?
Yes, ma'am.
Yes, good.
Yes, ma'am.
Okay, can you see my screen?
No, ma'am.
No, ma'am.
Can you see it now?
Yes.
Yes, ma'am.
Okay, good. So we continue from where we stopped. So we have identified the law that we are using, which is for the mechanical energy. We know the formulas. And we've also identified that since the potential energy in this case is gravitational potential energy, therefore the formula we will use will be mgy. My next question was that is this mechanical energy conserved or not? Is this a case of a conserved or a non-conserved energy system? Yes. Can you please answer this?
Not conserved, ma'am.
Huh?
Not conserved.
Not conserved. Why?
Ma'am, because there is a frictional force.
There's a frictional force, and we know that frictional force is not a conservational force. And therefore, this is a non-conservative system, and hence we will have to use the formula in which we also have to include the thermal energy. So we will have to use this, where the thermal energy we know is equal to the product of the frictional force multiplied by the displacement. So in this case, we have to use this formula. If it was a conserved force, there was no friction, then we could omit this frictional energy or the thermal energy. Okay, so we have to use this formula. Now the next step is that we have to identify what is E mechanical 1 and what is E mechanical 2. E mechanical 1 is the potential energy, and therefore this is mgh. H is the height. And we know that in the beginning, the potential energy will be maximum and the kinetic energy will be zero. At a maximum height, the potential energy is mgh. Here at this position, u is equal to mg multiplied by the height, and at the top position we know that k is equal to 0 because the body has not yet started moving. Okay, now when the body starts moving, we know that, and it reaches and stops. When something stops, reaches the bottom, the height becomes 0. If the height becomes 0, then u becomes 0. So in this state, u will be equal to 0, and kinetic energy will change, right? Okay. And if the rocks completely stop and the velocity becomes 0, then the kinetic energy will also become equal to 0. And therefore, we will say that the total E mechanical 2 will be equal to 0. So E mechanical 1 is equal to mgh. This is mgh. This one is mgh, which is the potential energy. E mechanical 2 is equal to 0. And now let's look at the forces that are acting on this body. Now, we have to make two diagrams, one for the inclined part of the motion and one for the horizontal part of the motion. So for the inclined part of the motion, again, according to the Newton's laws, we know that perpendicular to the body or the rock in this case will be the normal force. And since we are calling this state 1, so therefore this is Fn1 is the normal force. And the gravitational force acts downwards perpendicularly, but we have to consider the component of the gravitational force which is opposite to the normal force. And this component, if you make a right angle triangle, then you can, according to what we studied previously, this component is mg cos theta. So the component that's applicable in this case is mg cos theta for the part of the force that will balance the normal force. The normal force and the mg cos theta force will balance and cancel each other because the body is not moving in this direction, but in the other direction along the incline the body is moving, and the component of this force mg, the force was mg, its one component is mg cos theta, the second component is mg sin theta. So this is the component that will be acting opposite to the frictional force, which will be trying to oppose the motion of the rock. And therefore, since the rock is moving, this mg sin theta is greater than fk1, the frictional force. Okay, so this is the part of the force diagram for the inclined motion of the rock. After that, when it comes to the horizontal part, then we see that the motion is along the x-axis, and therefore the forces acting in this case, again the normal and the gravitational force, they balance each other and they cancel each other, whereas the frictional force in this case is fk2. Okay, now in this case, we have determined the mechanical energy for the first part of the motion. We have determined the mechanical energy for the second part of the motion. But we have to find the thermal energy change. The thermal energy change will now be, for the first part of the motion, it will be fk1 multiplied by d1. And for the second part of the motion, it will be fk2 multiplied by d2. Okay. So therefore, we have to factor in these quantities and we have to write them here and in the equation, and then this part was 0 and this one was mgh. So we continue from here. Now d1, in this case, this is d1, and again this is a right angle triangle, and according to Pythagoras theorem, right, we can use the sine ratio to determine the value of d1. We know that sine is equal to what? Sine is equal to opposite side divided by the hypotenuse. The opposite side in this case is h. So h divided by d1 will be equal to sine theta. And then therefore d1 will be equal to h divided by sine theta. So you can find this. And then for the kinetic frictional forces, we can use the equation that we had, in which the kinetic frictional forces is equal to the coefficient of friction mu multiplied by the force. We studied this in chapter number 6. So on an inclined plane, the normal force offsets the component mg cos theta of the gravitational force. And similarly from chapter 5, you see all these concepts are repeating. The concepts we are using to solve this problem, we are using concepts from all the chapters that we have studied. Okay, so they're all interlinked. We're using the formulas from chapter 5, we're using the formulas from chapter 6, because they are repetitively being used. So we have the value that comes after